Now let's look at another problem. We have given an LRU cache, its capacity. So we'll have a variable capacity over here and we'll set the capacity to the given capacity, right? Now see, we will have a doubly linked list where this is our head, this is our tail. On the tail side, we will store the least recently used cache and cache memory location. And here we will store the most recently used, right? And we will remove this from here, right? And we will store the mapping in a map. For example, we are given here 2 LRU cache and of size 2. So we can have at max 2 nodes here, and we will have a mapping. So mapping of 1 will give 1, correct? And we will store it here 1 1, right? Now 2 will give 2. That is recently added, so we should keep it on the right hand side, on the left hand side, sorry. So now when we want to get 1, it is present, so we will simply print 1, right? We will show the map here only. Now 1 got printed. Now 3 we need to store. 3 will come on this left hand side and its map, the value will be 3. Now when we are accessing 2, like when 3 is inserted, the capacity was 2, so this should be removed from here. Now, now when 1 was accessed over here, then 1 should replace, 1 should come on the right left hand most side because it is recently used. So we will put it on the left hand side of 2, like that. And now 3 will be inserted. When we will insert 3, we will remove this 2, correct? The left hand side thing we will remove. Now 3 and 1 are in the cache. Accessing 2 now will return -1 because 2 is not present. Accessing 4 will also return -1, right? But 4, when we will insert, 4 will come over here and 1 will get removed. Now accessing 1 will give -1. Now accessing 3 will definitely give 3. Accessing 4 will definitely give 4 because they both are present here. Now let's solve this, let's code this solution. So we need to have a doubly linked list. To have a doubly linked list, we will define a structure where a node will have its value, its key, its value, and the pointer to the next node. We can call it right, and the pointer to the left node, right? Like this will have a pointer to the left and pointer to right. Now, when a node is gets initialized, what we want to do is its key should be there, should be provided, its value should be provided, and we will set the key to key and value to value. Okay, now what we need to do next is we need to give a default value of 0, 0 if we have not provided with it. Hmm. Now, when we try to get a key, we will simply look it into the map. So we'll take an unordered map of integer to integer. We'll call it MP. Now the map will store this mapping from 3 to 3. It will map. right? So I guess we don't need to store the value as well. We can. Okay. Okay, let's proceed with it. Now, when we need to get a value, we'll look for the value in the map. If the map has a count of key, then we can simply return the key, then we can simply return MP keys value. Before returning, what we will do is we will move to front the node, the MP key. MP key will represent to a list node, pointer to a node. It, we like if two got accessed, we want to move it to the front. Move to front will do that. Now, how move to front will work? Let's define it. Now, it will take a list node, node key. Now, it should delete the key, like remove key, remove from tail, the uh, from tail. Instead of from tail, the key should simply be removed because if one got accessed, it should be removed from here and inserted over here, right? So we will simply remove the key. Otherwise, what we will do in the get call, if map does not have that value, we will simply return -1, right? Now, after removing that key, right, after we have removed, we will insert the key to front. Now, mm, what the remove function will do, it will take the key and it will set keys previous next to keys next and keys next prev to keys prev. Like it should set this next to this and this prev to this, right? So remove function is correct. Now we need to define the insert to front function. All right. Now to insert to the front, we need two nodes like this head node and this tail node. Let's define those. When we start the LRU cache, we need to define head to a new node and tail to be a new node, and heads next should be pointing to tail and tails prev should be pointing to head. Now the doubly linked list is successfully created. Now we want to insert the node to here in the insert to front function. So let's insert it over here. Hmm. So what we are going to do is, hmm, yes, so the keys prev should be head, keys next should be heads next, and heads next should be key, right? And what else is remaining is keys next prev. Okay, should be key. Yes, that is all we need to do. Now the get function is completed, it will work as it should. Now let's work a bit on the put function. The put function should put the key and value pair to the doubly linked list and to the unordered map. So the unordered map, if the map already has the key, we just need to update the its value, right? It got inserted, so do we need to bring it to the front as well? That's a question. We'll see it later, right? Hmm. Hmm. So I guess not. I guess it should work fine. Now, what we need to do next is, if map doesn't have the key, we need to insert the key to the front, to the heads next, right? Yes. So heads next should be equal to what? Heads next should be equal to new node, which should have key and value, right? Let's define it TMP. Now TMP's brief should be head. Okay, we have already defined this insert to front function. We'll just simply call insert to front TMP. Okay, else, okay, if the map already has the key, then then we should remove the key as well, right? We'll call the remove function. Like if the map has already has the key, so that should be already there. Then we will do this. We'll simply update the value. Otherwise, we'll do these things. Yes. Also, if the map does not, um, if mp.size exceeds the capacity, then we'll simply erase the least recently used thing, which should be in the tails brief. All right. We'll erase the tails previous key from the map. So, for example, this 2 got deleted, right? If a map already has, then it should be the value should get updated. If the map doesn't have, we will insert to front it and we will erase and remove the last node as well. So, so let's remove the last node, tails preview. Hmm. it should be working fine. Okay, instead of next, we were using left and right. So we'll define next and pre only. Okay, map of key should be storing what? Instead of value, it should be storing hmm, MP of key is MP of keys value should be updated to value. Temporary is new node with the key and the value. Value should be put here. Okay, we got a negative one over here, as it says that it did not found it in the map. So we did not insert anything in the map, I guess. Yes, yes. In the end, MP should get the key value pair. The TMP should be there. Okay, so we got one over here and two was there in the map. Two was not, two did not got erased. So let's do step by step what is happening. Okay. Hmm. When one got access, two should move here. When one got accessed, get of one when it was called. Then we are moving to front, this one, and we are returning its value. Okay, we can try printing. Hmm. All right. Add should be updated to new node. How can this cause this error? Okay, you can try like when we are inserting into when we are putting into here a value key value pair, we should move it to front as well. Okay, now after inserting, Okay, so we needed to insert the key before we are checking the capacity so that it results in the correct output.